this video, we will talk about abstract class in Java. Let's begin this with an example. So in the previous video, we already spoke about animal inheritance tree, right? So what is happening here? You have 5 instances: lion, tiger, cat, wolf and dog. These are the instances for which you create objects, because lion, tiger, cat, wolf, dog exist. These are the real creatures. And what these classes: animal, feline, hippo, can, like hippo is also the real creature, and for this also we create the object. But if you consider this animal, feline and canine, these are not the real creatures, right? So what we have done is just to avoid the code duplication, because like there are few features or few methods that are common, few instance variables and methods that are common to all these animals. Instead of putting that method instead of putting that methods in each and every class, it's a duplication of the code, right? That's why what we have done is we have created a superclass called animal, and this superclass is applicable to all animals like lion, dog, parrot. Here I have given only 5 animals. It will be applicable for all. What it has done is it has taken out all the common creatures that all animals has, and then it has put in this superclass. Using this, if your child classes like subclasses lion, tiger, cat, if these extend this animal class, they can reuse the methods, like whatever the method implementation that you have provided for sleep method here, that can be used by lion, and that can be used by tiger as well, that can be used by cat as well. So what we have done is we have removed out the common characteristics or the common state, and then you have put it in a superclass so that the code duplication is avoided. And coming to this feline and canine, it's the roam method. This particular roam method, even in the category of animals, there is a subcategory like lion, tiger, cat. They roam in a different way, and wolf and dog, they roam differently. So, but dog and wolf roaming behavior is same, and lion, tiger, cat roaming behavior is same, but it is different from this category. So that's why what we have done is instead of putting roam of method inside each and every class, what we have done is we have created another subclass for the animal, in which you have taken out the common roam behavior present in these 3 classes and you have added it here. So whatever we have done for the animal class and the feline class and the canine class, these are just to avoid the duplication of the code, right? But you should not create objects for these 3 classes like animal, feline and canine, because these are not the real creatures, right? And let's consider another example also. You say, usually people, like we say persons. Like if you say person does not really exist, right? Because you can say, like what you can think is, like let's say you think about human beings. Each and every human being has 2 legs, 2 cat, 2 eyes, right? So those are all the common characteristics for each and every human being. Instead of putting those state variables which would be common for each and every human being, what we do, we create a superclass and we let subclasses extend that. Like let's say I am one person and my friend is another person. Though the number of legs, number of hands and number of eyes are same for both of us, the behaviors could be different. Like let's say my name would be different, like my name would be different from hers. So those specific variables or the methods that are specific to the persons will be put in the subclasses, but the common behaviors we have put it in the superclass. But whatever the common behaviors you have put in the superclass, you cannot create objects for that, because those doesn't exist at all. Because when you say human being, you have to represent one person. You have to look at one person and say that, like let's say I am the person, then object should be created for me, not for the superclass in which I have put the common characteristics, right? So these kind of examples are there. Like these are just the sample examples, but these kind of instances or the examples exist while designing the program, while designing the system, right? So in this case, what you want, you don't want objects to be instantiated for animal class, feline class and canine class, because you should not do that. These are not the real creatures. Then you might say that what is the need for putting these super classes? What is the need of creating these classes when you don't want objects to be instantiated? Now there are two use cases for which you have created the classes but don't want the objects. One is you for the duplication of the code, for removing the duplicate behaviors, like since all the animals has few common characteristics, instead of putting in each and every class, you can take out those common characteristics and put it here. This is to avoid the duplication of the code. And another thing is for the polymorphic behavior. And we have already seen, right, in the previous video about the polymorphism. What we can do is we can create a reference variable animal, and to this you can assign anything. You can assign hippo, you can assign dog, you can assign anything. Using this animal reference variable, what you can do is you can create an array of animal, and you can add different kinds of animals, and you can use this animal as a polymorphic argument and the return type as well. So to avoid the duplication of the code and for the polymorphic behavior, we have created these super classes, but we don't want objects. Like how can you do that? Like you create a class but you don't want objects. How can you do that? Java provides you a simpler way for avoiding the creation of objects. That is, you should use the abstract keyword on the animal. Like let's say like this is it. So this is the animal class. Now let's say I remove this abstract first, and then what I'll do is I'll test this. Like I'll try to create an object for animal. Like we can see here, I'll try to create an object for animal. Now if I create object, works perfectly fine, but we don't want that. So to prevent keyword on the class definition, like add abstract keyword. Now if you add abstract keyword, Java compiler, even if you try to create objects, Java compiler throws error. If you try to create objects for the classes for which there is an abstract keyword, it throws error. Let's see. Before it did not throw any error when you did not add abstract keyword, but here if you add abstract keyword, it is throwing error. See, animal is abstract, cannot be instantiated. It is saying animal class is abstract, so you should not instantiate the class. Okay. So to prevent creation of objects for the classes, what you have to do, you have to just add keyword abstract on the class definition. Then that's it, you are done. Java takes care of that. Java will not allow creation of objects for that class. And the use case, the reason why you should declare, like why you want to declare a class as an abstract is you don't want objects to get created, right? You don't want objects to get created, and that is the only reason for adding the abstract keyword here. And this is for the class, like you have declared your class as an abstract, that's fine. There are abstract methods as well. Okay, so what is mean by an abstract method? Now let us consider a scenario where you thought of writing one common behavior for each and every animal. Like for lion, there is a behavior, or there is some method for lion, dog and cat and wolf, but the implementation of that method varies from animal to animal. Like let's say I add one method called public void print features. Now what happens is, like I want to print features for each and every animal, but I don't know what implementation I should put, or if this implementation varies from one animal to another animal, then there is no need of putting that implementation here. Let's say I add some implementation here, but this implementation will not be used by any animal, right? Each and every animal has its own implementation for print features, or you don't think of any common thing as well, common implementation as well. Now let's say even if I add print features here, I don't think of any common implementation that I should add here, because if each and every animal is behaving differently, how can you take something common and put it here? You can't do that, right? If there is something in common, then only you put it, but here there is nothing in common. That's why what you want is, since I am not thinking of any common implementation, let my subclasses add their own specific implementation. Let my dog class handle this method. Let my dog class add the implementation for print features. Let my cat class add implementation for my cat implementation for print features. Let hippo takes care of the print features implementation. Let each subclass adds their specific implementation for print features. So in this case, since I don't have any common implementation, what I'll do is I'll not add any body here. I'll just put semicolon here. I should not add even the empty implementation. Empty implementation is also considered as an implementation, right? For me, I don't know about any implementation. So that's why in this case, what you have to do is you have to add semicolon at the end of the method. Now, if you add an empty method like this, like a method with no implementation, this method is considered as an abstract. Like you can't directly add a method with no implementation. You have to add abstract method. If you encounter a scenario where you don't think of a common implementation, you don't add body. But if you don't add body, Java doesn't let you do that directly by putting the semicolon at the end. Like let's see the error. What it is showing is missing method body or declare abstract. Now it is warning you that you are not adding body. If you are intentionally not adding the body, make it as an abstract. Okay. So abstract methods are the methods for which there is no implementation. Okay. Now we already spoke about the abstract classes, right? So we are talking about abstract methods. So abstract methods are the methods for which there is no implementation. Now what happens here is you declare animal as its normal class. You did not declare this as an abstract class, okay? And what you have done, you have added abstract method here. It is throwing error. Why is it throwing error? It is throwing abstract method in non-abstract class. So, like if in a class, if you have at least one abstract method, you should declare that as an abstract class. Okay. Now, if you add any abstract method in your class and if you don't add abstract keyword on your class, then Java throws error. So, two main reasons for adding abstract keyword on your class. One is you don't want objects to be instantiated for your class. That is the one reason. Like even if you don't have this abstract method, you can still go and add abstract because you don't want objects for this animal. And the second reason is you have abstract method declared in your class. If you have at least one abstract method, then you should mark your class as an abstract. Two reasons for marking a class as an abstract. Either you don't want objects or you have at least one abstract method. Okay. Now you have declared this method as an abstract. What happens next? Now you don't have any implementation for this. Let's see the subclasses of animal. Let's go to the hippo. Now if you think about hippo, and this is the hippo. Hippo is extending the animal. It throws error. Why is it throwing error? If you look here, class hippo must either be declared abstract or implement abstract method print features in animal. So we have already discussed, right? The main reason for adding an abstract method is you want your subclasses to add implementation. Now hippo is my subclass. So hippo should add implementation for print features. Okay. That's why it is throwing error. What Java compiler does is first it will go to extends. Like if it finds extend keywords, it goes to its superclass and it sees in the superclass are there any abstract methods. Okay, there is an abstract method. Then you should provide implementation. If you are not willing to provide implementation, you mark yourself as an abstract. So the result here, let's say you don't want to provide implementation for hippo, and what you have done, you have marked yourself as an abstract. Then what is the disadvantage here? You cannot create instances for an abstract classes. Now you can't create objects for hippo, which is the major problem for us. You want to create dogs, cats, hippos, objects for these classes, and since you are not willing to provide implementation for print features, you are marking your class as an abstract, which is leading to another problem. So let's say now what happens is, let's say my superclass, now let's consider hippo. The hippo superclass is the animal. Okay. Now let's say my superclass has at least one abstract method. I have two options. I am the subclass, I have two options. Either if I don't want my subclass, like if I don't want objects to be created for my subclass, for my class, then I'll also go as an abstract. That is one option. And the another option is that's fine. I don't want to provide implementation, and even that is fine for me, even if I don't want objects for my class. Then in that case, you declare this as an abstract. First thing is provide implementation. If you provide implementation, you can create objects. If you don't provide the implementation, then you declare yourself as an abstract. In that case, the disadvantage is you cannot create objects for this class. There are two options here. Okay. Now, let's consider another thing. Let's say this is with single abstract method, right? Now let's add another abstract method as well. Abstract void, like test abstract. So in this case, what is happening? Now my hippo class, if I provide implementation, let's say I provide implementation here, public void print features. Like I provide default implementation. What Java cares is it should provide implementation for the abstract method. It doesn't care what implementation you are adding. Even if it is an empty implementation, it is perfectly fine. Now you might think that okay, I have added implementation for print features, though it is an empty implementation. Why is Java still throwing error? If you look here, class hippo must either be declared abstract or implement abstract method. So if you look here, it has two abstract methods. If I remove this abstract method, then it will not throw any error. Because what you have done, you have provided implementation for print features. But if you add another abstract method and if you want your class to be declared as a concrete class, then you should provide implementations for all abstract methods. Okay. So classes are of two kinds, abstract classes and the concrete classes. So abstract classes are the classes which has abstract keyword before the class, and if there is no abstract keyword, then that means it's a concrete class, and we can create objects for the concrete classes but not for the abstract classes. Okay. Now in this case, what I have to do, I have to provide implementation for all. Public void test abstract. Now in case, let's say if you don't want, like you don't want, like let me don't declare it, and if you don't provide implementation for these two, right, then you should declare this as an abstract as well. Okay. Then let's say you have your subclass, like you declare this as an abstract. Okay. And you might have another subclass for this hippo, right? Hippo should provide the implementation. Like this continues, like animal has abstract methods. Okay. Then hippo should provide the implementation. Hippo is the subclass of the animal, it should provide the implementation. Even you don't want to provide the implementation, then the subclass of hippo should provide the implementation. Okay. So like they can pass on the abstract methods if they are not willing to provide the implementation, or if they can provide the implementation, then they can allow the Java to create objects for that class. Let's see another example. Okay. Now this animal, you have animal, and if you have canine, right, what happens? Canine extends animal. Let's see. Canine extends animal. I don't declare this. You can consider this diagram. Okay. Animal. Till now what we have done? We have checked this particular path in the inheritance tree. Let's see this path. Animal to canine and the canine to dog. So what happens here? Well, now if you see, it is throwing error because class canine must be declared abstract, or it should implement the abstract method. So if you see the animal class, we have two abstract methods. Now since canine is extending, either it should provide implementation or it should declare itself as an abstract. Now canine is not providing any implementation, so it itself declared as an abstract. Now let's go to lion. If you see lion extends, not lion. Let's go for dog. Yeah, dog extends canine. If you see dog here, dog is extending the canine. Yeah, dog extends canine. Let me remove this print features and then yeah. Now dog is extending canine. Now if you go, it is throwing error. What it is throwing? Class dog must either be declared abstract or implement abstract method. Now you might wonder, you go to your superclass, and my superclass don't have any abstract methods. Then the important thing to note here is, it's not just your immediate superclass. It will check for the super class as well. Now for the dog class, in the canine you don't have any abstract methods. But canine extends animal. Animal has abstract methods. If your canine would have taken care of providing implementations for these abstract methods, then dog should not have implemented. Your dog class shouldn't have got this error. Since canine did not implement this method, it forwards Java forwards it to the next subclass. Okay. Now, like here, I want objects to get created for the dog. So for sure, I want to provide the implementation. If I don't want objects to get created for the dog, then I can provide this as an abstract also. Then the subclass for the dog should take care of instantiating the or providing the implementation for the abstract methods. So you have seen here, right? Let's say you have one abstract method here, one abstract method. If canine provides implementation for this abstract method, then no issue. This dog and the subclasses in this inheritance tree need not worry about that abstract method. But if canine did not provide implementation for this abstract method, then this abstract method has to be implemented by this. Then even dog don't want to provide implementation for the abstract method that is present here. Then in that case, the subclass of the dog should provide the implementation. So it goes down. It keeps going. Okay. Yeah. And one more thing is, let's say in the animal methods, canine would have provided implementation for one method like public void print features. But still, like let's say print features. But still, this is an abstract class. If I remove this abstract class, it throws error because it should provide implementation for all abstract methods. Okay. Now, when you say your class has that class, you should have like implementation for all the methods either in your class or in your super class. Let's say I declare this as a concrete class. Okay. Non-abstract class. Then in this case, either canine or the animal should have implementation for all methods. Let's say in the canine I have implementation for all methods. Let's go to animal. Oh, in the animal there are two abstract methods. But for print features canine has provided. But for test abstract there is no implementation. So it is still an abstract class. Okay. Now in this case dog should provide implementation. Like here dog should provide implementation for test abstract because canine has already provided implementation for print features. Then you should provide dog should provide implementation for, let's say dog provides implementation for test abstract, just test abstract. Okay. Now in this case you don't see any error because what Java compiler does is it sees all methods. Okay, all methods. There is no abstract method here. It goes to canine. There is no abstract method even in canine. It goes to animal. There are two abstract methods in the animal. But one method implementation is provided in print features and the other method implementation is provided in the test abstract. And for animal there is no super class. Okay, dog can be considered as a concrete class. Okay. So there are two kinds of classes, abstract class and the concrete class. Now in this particular inheritance tree what we have done, here animal class is an abstract class, feline is an abstract class because you are not creating the objects for this. And then canine is also an abstract class. And the lion, tiger, dog, cat, all these are the concrete classes. Okay. Now let's recap what we have discussed till now. We have discussed about abstract classes and abstract methods. Abstract, like you declare a class as an abstract in two scenarios. One is you don't want Java to create objects for your class because of the design you have prepared. So in that case, you can declare your class as an abstract. And the another thing is method in your class. In that case also your class becomes an abstract. Okay. And then coming to the abstract methods will not have any implementation. And if your class has at least one abstract declared as an abstract, and the implementation for the abstract methods should be provided by the subclasses if they are willing to, if they provide the implementation for the abstract methods, if your subclasses, then those classes will be marked as non-abstract or concrete classes. If even your subclasses will not provide implementation, then those classes also will be declared as an abstract. and the this particular subclass of the Kenneth should take care of the implementing the abstract methods. Okay, and you might wonder, what you might wonder is, okay, since I am not providing any information for print features and the text abstract, what is the need of even mentioning it here? Now, if you have seen, if you have marked these methods as abstract, then Java is forcing you to provide the implementation in your subclass, or it is asking the subclass of. Okay, now it has gone to the dog. It is asking, forcing dog to provide implementation for the abstract method. Else even dog should itself declare itself as an abstract. But which dog, anyway dog wants objects, like dog wants dog objects, right? Then it will for sure provide the implementation for the abstract methods. That is what even we want. Like we have declared few methods for which you don't want it, like you don't know implementation and you want your subclasses do that. So by making these, you are forcing your subclasses to provide the implementation. Let's say you don't do these methods, okay, you don't put these methods as an abstract here. Then your dog and cat, you don't declare at all these methods, then your Java will not throw any error. Dog might provide implementation for print features and cat might not provide and even hippo might not provide. It's up to them, right? Since there is no restriction, few subclasses might provide implementation, few subclasses might not provide the implementation. And even if they provide implementation, they might use a different name, like instead of print features, they might say print state. But you want a protocol. Like if a person comes and sees this inheritance, by looking at just the superclass, what they see is, okay, these animals, like whatever the subclasses that comes under the animal, has these 4 methods and has these instance variables. Okay, this is acting as a protocol or contract also to outside world. Now, if you don't add print features here, then the person who is getting a contract by just looking at the animal will not know about the print features. So, 2 reasons for marking the methods as an abstract. First thing is you enforce your subclasses to provide the implementation, and the second thing is since you added this method, it's like a contract or a protocol. Okay, yeah. Hope you understand about the abstract classes and the abstract methods. Thank you.